Hi everyone, girls and boys, your study should be instrumental for your IIT Advanced, Main, Neet, KVPY, various Olympiads as well as for your intermediate. Today we are going to discuss one of the important topic or useful topic for your wave mechanics, for your physics. We are discussing today Doppler's effect. Okay, uh, you know, frequency is everything for communicating purpose, for communicating message, for communicating data. Frequency is everything. Frequency reflects your message, your data, your message, your data, your pronunciation, your word. Okay, means overall frequency is everything. Okay, now here in Doppler effect, when source and observer are in relative motion, once again, when source and observer are in relative motion, then observes frequency by the observer will not be the same as emitting frequency by the source. So, when frequency change, then obviously message change. Okay, by a small amount, by large amount, but message change or not? Yes, of course, message change. Okay, see here. See, you know about sound waves? Sound waves. When diaphragm of the speaker vibrates, you know sound is nothing but flow of propagation of, transmission of, transferring of pressure or densities, variable pressure flows from one location to other location. That is called sound waves. Okay, means sound wave क्या होता बच्चों? Sound wave is nothing but flow of variable pressure or oscillatory pressure or oscillatory density. Okay, now see, when diaphragm vibrates, so it releases some message. Okay, so when diaphragm vibrate, the nearby or vicinity of the diaphragm, air molecules vibrate, and hence air molecules transfer from here to here to here or everywhere, transfers what? Pressure variations. Okay, so here pressure varies, here pressure varies, here pressure varies, everywhere pressure continuously vary. Okay, everywhere pressure continuously varies, है ना? When sound source continuously emits sound, so everywhere pressure varies. Okay, now okay, see, you know compressions means high pressure zone and rarefactions means low pressure zone. Okay, this you know basics, huh? This is speaker. Suppose these two points are having same pressure. This point and this point having same pressure means this closest point having same pressure, so this distance is called lambda naught. Okay, And this takes how much time? The formation of lambda knot takes how much time? Called time period of diaphragm, called time period of weave. Okay, so this is lambda knot and this is time period. Okay, genius. Now, these pressures flow with what speed? Obviously, with the speed of sound. Okay. Now, suppose this one is source. Suppose source moving towards the observer. Okay. Suppose source is moving towards the observer. So this pressure, when both are fixed, the pressure here created and here created. But when the source moving towards the observer, the same pressure where created. So these two are the same pressures. The same pressures here now created in time period T naught. In time period T naught, vehicle, source, siren moving with what distance? Vs into T naught. So this is now same pressure point getting distance between same pressure point getting reduced. Initially was lambda naught. Now genius, this much. Okay, so you write observed. This one is observed wavelength by the observer. So how much? Actual minus Vs into T naught. Okay here. Now, could you write please? You should remember one point. Whatever frequency you deliver now in sound, in air, all frequencies, whether infrasonic, ultrasonic, audible frequencies, all flows with the same speed, because gaseous molecules here will not change, first, and second elasticity of the medium can't change. Okay, the both will remain unchanged. Okay, so please see, velocity of sound or speed of sound cannot change. Okay, bhaiya. So here you write this is observed wavelength by the observer. So could you write please velocity of sound by nu dash? Okay, again bachcho, here lambda naught, velocity of sound by actual emitting frequency of by the source, or here Vs, and at the place of T naught, could you write please 1 by nu naught? Yes, please. See. Okay, after solving this, you will get 1 minute. Okay, then you write V by nu dash, nu naught, V minus Vs. So nu naught you could see this is observed frequency. Observed frequency by the observer, obviously, and this is this one, actual emitted frequency by the by the siren. By the siren. Okay. So here this formula validates when observer rests and source is moving towards the observer along the same line. So this is your formula. Okay, keep mind this formula. Okay, now we used here two formula, speed of sound and frequency related with this equation, v equals nu lambda. This one is basics, but please pay attention here. You know, young mind, you know, genius, these two, suppose these 2 points, suppose closest same pressure points. Okay, so you know this one, lambda naught, and this takes how much time? Pressure, variable pressure transferring from here to here. How much time it takes? Then it takes T naught. Okay, then it takes T naught. Now please see here. This two pressure form and take time T naught. So here in this direction pressure flows, variable pressure flows in these directions. So you know what is the speed of variable pressure? What is the speed of variable density? Variable density flows. Okay, variable densities flows. So what is the speed of variable densities? Okay, or variable pressure? So could you write please this and this? The speed of variable pressure is called speed of sound. So you know, distance by time. Or please see, in one time period, please remember, in one time period, how many oscillations? 1 hertz. In one time period, how many oscillations? How many oscillations of diaphragm of source who emits frequency? The in time period T naught, what is the how many oscillations it creates? So it creates what? 1 hertz. So and hence in 1 second, the 1 second creates how many? 1 by T naught. So please remember, in 1 second, whatever the number of oscillations, again genius, in 1 second, whatever the number of oscillations, that is called frequency. So please, 1 by T naught is termed as frequency. Put this value in this equation. So you will get what? Lambda naught, 1 by T naught is nothing but frequency nu naught. Then you will get very famous formula, V equal to nu lambda. Speed of sound equals to frequency times wavelength. Okay, these two relations we used in aforesaid discussion. Okay, in previous discussion. देखो होता क्या है, डॉपलर इफेक्ट में होता क्या है? फर्स्ट ऑफ ऑल दिस इज वेरी सिंपल लॉ. कॉन्सेप्ट अच्छा रखो, कीप बेसिक्स गुड. ओके, फॉर फिजिक्स your basics important rather than your numericals. If you're strong in basics, then you will be tempted to grab, to accept those knowledge. Okay, after this we will discuss the second case, when source is at rest and observer moving towards the source along the same line. Namaste.